Manage the relate to the student. This is like 10
Going to divide the line paper into 4 columns. Do it right now. Draw 4 vertical lines. And I'm going to tell you what title to put for each one of them. Okay, I need for you for the first one, let's call the first column General Formulas. General Formulas, the first column. If you don't have time to write every word, don't worry, because I will keep on repeating them as we give you examples. General Formula, column 1. The second one, let's call it Election Domain Geometry. DOMAIN. Election Domain Geometry. Geometry. Yes, DOMAIN. Okay, we said general formulas. If you don't have time to write them, don't worry, I said. I'm going to keep on repeating them. The third column is molecular geometry. Molecular geometry. The fourth column will be bond angles. Bond angles. Let's start. I need for you to go somewhere else, or if you have any space on top of that column, any space, let's use some letters, okay, as symbols for those general formula. Write down capital A equal. Capital A equal central atom. Capital A equal central atom. No, you can put it somewhere else. This is a legend for your general formula. If you have space on top, yes, you can put it. If you have any space on general formula on top of it somewhere, write capital A equal central atom. Write down capital B equal terminal atoms. Capital B equal terminal atoms. Write down capital E equal a pair of unshared electrons. A pair of unshared electrons. We are going to use those 3 letters to come up with our general formula. Yes. Now, I need for you to look at that molecule right now. If I call the central atom A, the terminal atoms B, what would be the general formula for this molecule? Yes. BAB. If you are writing a molecule, what is another way you would write it? AB2. Under general formula, write down AB2. That means any molecule that would have that form is one central atom with 2 terminal atoms, and there is no unshared electrons on the central atom. No dots. Nothing. No dots. The shape of that molecule go under the second column, electron domain geometry. Electron domain. How many connections do you have around the central atom? There are 2 connections. That means there are 2 places where you have things. It can be bonded or unshared. Total. 2 connections. Whenever you have one central atom with 2 connections, we will call it linear. So, what on LINEAR? Linear. And for the third column, molecular geometry, the shape, that means the shape, the geometry, it is also linear. Do you see the shape? It is linear. Just like that. This is a project students did some times ago. You have a central atom, you have two terminal atoms, the shape is linear. Yeah, Linear, and I put the word is small on the screen, but it is there. Now, I said the first column general formula AB2. It's like a formula, capital A, capital B, subscript 2. It's like writing a formula. So we have the general formula, we have the electron domain, we have the molecular geometry. What do you think is the bond angle? What do you think is the angle between this atom and the other one? From here to here, it is 180. Okay, the bond angle is 180. So there is no pair of unshared electrons in the central atom. Now, this is our first example. Let's go with the second one. I'm going to choose another molecule. I will call this, I'm going to choose this one. What is the general formula for this one? It is AB3. Good job. Capital A, capital B, subscript 3. AB3. It's like this one. What do you think is the shape? It is triangle. Is it sitting on one plane or is it in 3D? Is it sitting on one plane? It isn't sitting on one plane. The name is trigonal planar. TRIGONAL. If you watch the YouTube video, you will have all the names right on the screen for you. TRI. Okay, when you watch the video, you will have all the spelling on the screen. Okay? Trigonal planar. So, under geometry, the third column, molecular geometry, right on trigonal planar, the same word, two words. Okay, the names will be on the screen for you, anything you are missing. That's what I said. When you watch the video, you can slow me down, pause me, do whatever you want. You choose your speed. All right. What is the bond angle? It is 120. From this one to that one is 120. 120. All right. Let's go with our next example. We are going to use this one. What do you think happened here? What is the general formula? What is the general formula? This has a pair of dots. This is a pair of unshared electrons. AB2E. Under general formula, write down AB2E. Let me tell you why we put that bubble on top here. That pair of unshared electrons needs more space than the pair of shared. It pushes the others down, make the bond angle smaller. Do you remember when we drew the Lewis structure for water, what I said? Okay, the pair of unshared need more space than the pair of shared electrons. AB2E. The shape is no longer trigonal planar because it is pushed down. The name is called bent. B-E-N-T. Good news. Okay, hold on one second. Don't put it on electron domain. Put it under the geometry, the third column. Molecular geometry, it is bent. Yes. Remember the spelling, you can get it from the screen. Alright? You can write whatever you can now. If you cannot read the screen, when you watch the video, you have the spelling. Alright. Now, how many regions around the central atom where you have bonded or non-bonded electrons? 3. What is the name we said when you have one central atom with three connections? Well, we don't have triple bond. Not only bond, I said three things around the central atom. Say that again. Yes. For the electron domain, it's still trigonal planar. For electron domain, we count everything, bonded and non-bonded. All right, let me repeat. For the electron domain, we will count bonded and non-bonded. This is for the second column. Okay, I don't want you to give me a specific angle, bond angle. Doesn't have to be specific, but you are comparing to what you had before. Do you think that bond angle from here to here, is it 120? Is it less than 120? Is it more than 120? Okay, I hear two different answers. Okay, the answer is less than 120. Because if I said that pair of unshared push the others more, they get closer to each other, it is less than 120. Okay? Let's move on to our next example. Let's go with this one. What is the general formula for this one? It is AB4. Under general formula, write on AB4. This is what a student made, AB4. How many faces do you see in this geometry? How many faces? What is the name for a geometry or shape that has four? Well, yes. How about if each face is a triangle? How do we form four faces? It is called a tetrahedron. So the shape is tetrahedral. The shape is tetrahedral. 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 It is for both because you have four things that are bonded or non-bonded. It is the same for both of them. Okay, you have four regions around the central atom with bonded or non-bonded. So it is for your electron domain. It is also for the molecular geometry. It is tetrahedral. Okay, for both of them. Let me open the name for you. When you watch it, you see the names. And then let me put the bond angle for you. It is not 90 because this is a 3D. It is not 90. I don't think anyone would guess that shape, that angle. It is 109.5. 109.5. Even if I move them around, when I leave them again, they will take that shape because the electrons repel each other. Okay, this is what we call the valence shell electron pair repulsion theory. VSEPR. All right, let's choose another one. Well, we are coming to water, but not yet. Let's go with this one. What is the general formula for this one? It is AB3E. AB3E. Let's see if you can figure out the electron domain. Let's see who can come up with the electron domain. I heard the right answer. What is it? It is tetrahedral because you have, we said electron domain because you have four things around the central atom. It doesn't matter if it's bonded or non-bonded. You still have four. But you don't have four bonded. There is a pair of unshared. It is not tetrahedral for the molecular geometry. It is what? It is triangular, but it has a shape. Someone told me the shape before. No, it is trigonal. It is sitting. It is sitting on a triangle, but what is the shape? It is a. No, someone else. I heard someone said it has the shape of a. I heard it. Pyramid. Okay, all right. So the name. All right, for the molecular geometry, for the domain, it is tetrahedral, but for the molecular geometry, it is trigonal pyramidal. Trigonal pyramidal. For the geometry, for the molecular geometry, it is trigonal pyramidal. It is a pyramid sitting on a triangle. All right, the next question. Whenever we have pairs of unshared, I don't want you to know specific angles. I'm going to ask, what do you think would be the angle for this one? Thank you very much. It is less than 109.5 because the electron domain geometry is tetrahedral. But because of that pair of unshared electrons, it is pushing more. It is less than what it should be. All right, your next example, someone have been asking for water. Let's do water. Let's find water. Okay, you see, you don't see. Let me show you the pair of unshared right here. What is the general formula? AB2E2. Doing a great job. It is AB2E2. Let's see if you can come up with the electron domain. Jacob, what do you think? Electron domain. Anyone? It is tetrahedral because there are 4 bonded or non-bonding around the central atom. It is tetrahedral. But do you think the molecular geometry is tetrahedral? Definitely not. It is bent. It is bent. So let me give you the name here. When you review the video, you can see all the details. It is bent. Remember, those 2 pairs of unshared electrons are pushing the bonded closer to each other. Okay, so it's pushing. That's why I told you when you drew the Lewis structure for water, don't show it straight because it is not really straight. You need to put those pairs of unshared electrons on one side and then push the others down. Let's see who can come up with a bond angle for me. I don't want specific bond angle. Yes, it is. Because it is tetrahedral, but it is less because of unpaired electrons. It is less. 109.5. Less than 109.5. Next, I am going to choose this one. What is the general formula for this one? It is AB5. It is AB5. Let me try to put it straight. AB5. Now, I have, this is what a student made. This is not a good one. AB5. Yeah, not quite right. Not quite right. How do you call a shape that has how many? Okay, what is the shape? This one is not a good one. What shape do you see here? Pyramid. But if we had it right, we would have, oh, right here. A pyramid. How many pyramids do you see here? Both of them are sitting in what shape? What shape that is holding both of them? This is one pyramid, triangle. This is a trigonal bipyramidal. 2 pyramids. Trigonal bipyramidal. What do you think is the electron domain? It is the same thing because the number of pairs equal the number of shared equal the number of unshared. So it is the same. Trigonal bipyramidal for both of them. So I need for you to look at this carefully. Why don't I put the bond angles for you? So between this one and that one, you see this? The bond angle is 90 because this is a plane. This is a plane. This is up. 90. 90. How about between this one and that one? Between this atom and that one, what would be the bond angle? It is 180. It is 180. How about between this one? You see the plane, the 3 in the plane? What do you think is the bond angle between this one and that one? Not between this one and that one. This is 3 on one plane. Between this one and that one. Are you looking at only those 3? Forget about this. Those 3. The angle between this and that one. 120. It is just like this one. It is 120. No, you told me 180 is from here to here, up and down. From here to here is 20, but from the top to that plane is 90. So you can write all 3 angles, but make sure you know which is which. We have 120 between this and this. We have 90 between this and this one. And we have 180 between this one and that one. Okay? Now I'm going to move to another shape. This is my favorite shape. This one. This one. Let's see who can come up with a name. Let's go with the electron domain first. Let me show the angle also. The lone pair. You have the lone pair here. It is AB4E. AB4E. What do you think is the electron domain? Say that again. It is trigonal bipyramidal because you still have a central atom with 5 things around it. Trigonal bipyramidal. Now, I said it was my favorite. I'm going to say, if I take this off so it won't disturb us, I'm going to take everything off. Let's see who can come up with a name. A name. Name. Not general formula. A name for this one. And if I to look at it carefully, don't be fancy. Don't think about science. Think about your childhood. Okay? Let's be simple here. No. I think it is a seesaw. Why don't seesaw? This is the shape. Yes, it is a seesaw. S-E-E-S-A-W. Seesaw. Just imagine 2 kids. One sitting here, the other one sitting on the other side. Seesaw. Up and down. Huh? Flip it. Let's see if I can flip it. This is a seesaw. Like that. That's how you have the seesaw. Okay. So... All right, so let's go with the next one. You see why it is my favorite? CLF3. What do you think would be the angle? Okay, why don't we just use less than whatever you had before? Less than 120. Okay? All right, we have CLF3, this one. Why don't I put the lone pairs for you? What is the general formula for this one? AB3E2. AB3E2. What is the election domain geometry? Say that again. It is trigonal bipyramidal. You still have 5 things around it. Trigonal bipyramidal. If I take the lone pairs off, it will be easier to come up with the shape. Let me take it off. I need for you to come up with a name for the shape. That's what it is. T-shaped. T-shaped. T. Letter T as in Tom. Say that again. T-shaped. Let me put the lone pairs for you to help you. What is the general formula for this one? AB2 E3. Now, I'm going to take this one off to help you see the shape. What is the shape? Okay, it is linear. It is linear. Well, what is the election domain? Someone already told me the election domain. Domain. Let me put those back. What is the domain? Trigonal bipyramidal. You have 5 things around it. It is trigonal bipyramidal. Now I take those off. You don't have to see them. What is the molecular geometry? It is linear. What is the bond angle? 180. Okay, whatever you had as the election domain, put less than. Every time we have pairs of unshared electrons, whatever you had for the election domain, put less than that angle, whatever angle it was. Okay. Let's go. 3 more to go, guys, and we are done. 3 more to go. Let me go with this one. What is the general formula for this one? It is AB6. AB6. I think I have an AB6. You need to know geometry to answer that question. How do you call a figure that has 8 faces and each, I heard it, octahedral? This is an octahedron, so the shape is octahedral. Octahedral. What is the election domain? What is the election domain? Say that again. I heard someone else. Octahedral, guys, because all of them are bonded. Same name. The shape and the election domain, they are the same because they are all bonded. Octahedral. What is the bond angle? We can come up with 2 different bond angles. We can call it 90 from here to here. Still 90. We can call this 80 or 180. Is that right? 180. Okay, so we already said octahedral. Let me put a name for you for this one. 2 more to go. Let's choose BRF5. BRF5. What is the general why don't I put the lone pairs to help you? What is the general formula for this one? What is it? Say that again. AB5E. It is AB5E. What is the election domain? Octahedral. You did not miss it. You still have everything around. What is, now if I take one thing off, I take one off, what shape do you see here? A pyramid. That pyramid is sitting on what? That pyramid, if I take one off, that pyramid is sitting on a square. It is called square pyramidal. No. What is the domain? Octahedral, because you still have everything around octahedral. Okay, let me take that off to help you see. Alright, if I connect everything here, you will see a pyramid. That pyramid is sitting on a square. We call it, let me put a name here for you. We call it square pyramidal.